All right, we are going to do regression in the calculator. You'll notice that you've seen this before. We did this whenever we wrote equations where we had the calculator do linear regression for us. The thing that we're adding to this for this lesson is the correlation coefficient and doing the line of best fit on the calculator. So looking back at our notes, we have correlation coefficient. It's the R value, and it describes the strength of a scatter plot. So we are going to get a number between -1 and +1 in a calculator that tells us the strength. Remember how we just kind of guessed it here? Our calculator will actually find us the exact number using mathematical calculations. We don't have to do the math for it. Our calculator is going to do it for us. And it's going to tell us how weak or strong the correlation is. So that's your correlation coefficient R. We're also going to the calculator to plot the scatter plot on the graph and also graph the linear regression equation, the line of best fit. Okay, so let's start off by looking at our instructions here. It says first, click mode, stat diagnostics on. So get your calculator, clear out your memory. Second plus 712. So I wrote that on the top just to remind you. So we're going to clear the calculator first. Then we're going to go to stat diagnostics by going to mode. Look at where my finger is. Mode is right here. Click on mode. And we're going to go down to stat diagnostics. You see it right here? Stat diagnostics. It's automatically set to off. We want to turn it on. So arrow over to on and push enter. So now on should be bolded or highlighted or whatever it's. Okay. So we have stat diagnostics on. Now we're going to follow the same instructions that we've done before, where we put in L1 and L2. We do linear regression, circle number 4 on this image of our calculator. And we're going to do linear regression to get our equation. So I went to mode and went down to stat diagnostics and turned it on. Okay, go to stat now, edit, and let's put our data in. This is like X, this is like Y. So it's really important that when you finish typing them in, you go back and double check that you typed in the numbers right. Because you could miss this problem because you just mistyped something in. So 1 is with 1, 2 is with 3, 3 is with 6, 4 is with 9, 5 is with 11. You got it in? Okay. Now go to stat again, and we're going to go to linear regression. So stat, over to calc, go down to linear regression, AX plus B. Make sure this says L1 and L2, and then go to calculate. This is what should come up. What we've done in the past is just get the regression equation, the AX plus B. Well, now it's giving us more information because we turned on stat diagnostics. It won't give you R or R squared unless you have stat diagnostics on. All right, let's go ahead and write this here. So R squared, we're going to round to 3 decimal places on this. I'm not going to make y'all write all of these, just 3 numbers. The correlation coefficient is R. It's not R squared. This is your correlation coefficient. You'll be asked that on a test. What is the correlation coefficient for this set of numbers or data points? You don't have to do the work. The calculator will do it for you. You just have to make sure you turn on stat diagnostics. So this R of 0.997 is really strong because it's close to 1. And it's also positive. So this is a strong positive correlation. Just put strong positive. The closer it is to 1, the stronger it is. It can't be over 1 though. It's 1. 1 is the highest, -1 is the lowest. But any R value that's close to 1 or -1 is strong. All right, so here's where we're going to do some more things with our calculator, so you've got to pay attention. It says, to see the data, turn on stat plot, second y equals. So do you see in blue where my finger's pointed, it says stat plot? In order to get to that, we have to push the blue button second. So second y equals. See if your screen looks the same as mine. We're going to turn plot 1 on. So push enter, and it looks like this screen here. But we want to turn it on, just like we turn on stat diagnostics. Turn it on. And we're going to graph it. So hit graph. So what it's doing is it's plotting the scatter plot for us. But the thing is, I can't see all the points. So number 8 is important. To see the data on the graph, push zoom and choose number 9, zoom stat. Zoom, right here, middle button on the top. Find zoom stat. And that's what it should look like. So I'm going to come around and check. Okay, so this looks the same. So the last step is going to be put the line of best fit in our calculator by putting in the regression equation. So we found the regression equation already, y equals ax plus b. So the regression equation is y equals 2.6x, because that's your slope, it's the a, plus a negative 1.8, or just minus 1.8. Either way is fine. So this is the equation that's going to go over the top of these data points, like our line of best fit that we did yesterday. So go to y equals, let's plot it. So put in 2.6x plus a negative 1.8, or you can just put minus 1.8. And then hit graph again to see what happens. What did it do? Put a line right through the points. So we're going to draw that line on here on our scatter plot. So it looks like it's above this last point, below the first point. Kind of looks like that. So that is your line of best fit, or your linear regression line. We're using our calculator to help us estimate where that line is. All right, let's look at the next one. It says, convenience store manager notices that sales of soft drinks are higher on hotter days. So he assembles the data in the table. We have some data. Step 1 says make a scatter plot of the data. We're not going to use our calculator first. We're going to plot it on here first. Okay. So we're going to look at what the X values are. That's high temp. Y is number of cans sold. So we need to label our X and Y axis. So I'm going to label it here, but don't put it too close to the line because we're going to have to put the numbers there. So go ahead and just put high temp. That's our X-axis. And our Y-axis is number of cans sold. All right, so we've got to put our data on here, but we need to come up with a scale. So let's look at the X values, which is high temp. It goes from 55 and the highest is 84. So we've got to be able to put that all on here. Like 30 plots, 30 numbers there. Do you remember this thing? That means there's a break in the data. So we can just kind of skip some numbers and start with, I'm going to start with 50. And I want to go all the way to at least 85 or 90. So I'm going to go by fives, but I'm only going to label every two. So I'm going to skip. So it'd be 55. This would be 60, 65, 70, 75, 80, 85, 90. That's as high as I need to go. The highest one is 84 on the axis. Okay, look at the Y's. Number of cans sold. 340, 335 is actually the smallest. The largest is 780. I could probably go by hundreds. To fit them all on there. So 100, 200, 300, 400, 700, 7, and 8. I don't have to go any higher. Let's plot the data. So 55 is 340. You can do this on your own or you can do it with me. I'm going to go to 55 on high temp and go to 340. 55 would be in between 50 and 60. 340, halfway between 300 and 400 is 350. So I'd go a little bit below halfway. Then 58, 335. 64, 410. They don't have to be perfect, just in a roundabout area. 70, 450. I don't think I did 68, 460. 75, 610. 80, 735. 84, 780. So I should have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 points. Okay. Part B says find and graph a linear regression equation that models the data. So now I'm going to clear out the memory on my calculator. Second plus 712 and start fresh. In order to have the R show up, I've got to turn on the mode, stat diagnostics. So do that first. Follow along with me. Mode, turn on stat diagnostics. Then go to edit, stat, edit, put in all the numbers from the table. So it's important that you double check your table to what you put in the calculator before you do linear regression. So 55, 340, 58, 335, 64, 410, 68, 460, 70, 450, 75, 610, 80, 735, 84, 780. And make sure there's nothing uneven down here. Now go to stat, over to calc, and we're going to do linear regression. We're going to round to 2 decimal places on this. So this is our equation. It gave us A, which is your slope, because see how it says AX plus B, so A is your slope. 16 points. I'm going to go to 2 decimal places. So remember, you go, if you're doing 2 decimal places, you go to the third. 5 or more, raise the score. 4 or less, let it rest. That'd be 4, 2. X. And then negative 6, 21.8. 6 is going to make the 2 go up to 3. So we have our equation. And then we're asked what is the correlation coefficient? That's the R, not R squared. We don't care about R squared. We just want R. We're going to round to 2 decimal places on this too. 0.9. The 7 is going to make that 6 go up to 7. So 0.97. So if it's 0.97, is that strong or weak? Yeah, it is strong. And is it positive or negative? It's positive. Okay, let's put it on our graph. So go back to y equals, and let's type in the equation. Type in the equation. You don't have to put plus negative. You can just put minus. Once you have the equation in there, hit graph. Oh, I haven't turned on stat plot. We got to go back to second y equals. Turn stat plot on. Second y equals for stat plot to be turned on. And then see if we can see it. Can't see it yet. So you got to go to zoom. Which one do I choose? Stat, zoom stat. And there it is. So draw this line best as you can. We want to use the model to predict if soft drink sells. Oh, predict the soft drink sells if the temperature is 95 degrees. The highest degrees that we have here is 84. So we want to find for 95 degrees. So we're using this model for when it's 95 degrees. So when X is 95, what is the Y value? So what we can do is we can plug in 95 for X and find out what that equals. So we're going to use the model, this equation. So 16.42 X, well, X is 95, plus a negative 621.83. So go second quit to get back to the home screen, and you can put this in. So when X is 95, so when the temperature is 95 degrees, you could predict that 938 cans would be sold. So at 95 degrees, there would be about, because we're predicting, 938 cans sold. We're going to wait on example 2. We'll come back to that tomorrow. And I'm going to pass out an assignment. You're just going to do problems 1 and 2.